All right, as promised and as longed for, let's talk about Arrhenius acids and bases. Okay, so we've already talked about the autoionization of water. And what I need for you to understand completely is that Arrhenius dealt specifically with acids and bases in water. Everything was dissolved in water. And when you see that, this aqueous, you're going to notice that for the majority of the time, generally that's going to be water. But Arrhenius acids deal with water. They also deal with the concentration of hydronium, or that proton hydrogen, and the concentration of OH minus. Now, concentration, remember, can be notated as molarity, and really what that's saying is how much of it is in solution. How much hydrogen is in that solution? How much hydroxide is in that solution? How much? What's the molarity of it? What is the concentration? Remember, these brackets represent concentration. And so Arrhenius dealt with water and concentration. Here's his definition of an acid. Arrhenius's definition of an acid is a substance that yields H plus ions in water. Okay, and his definition of a base was a substance that yields hydroxide ions in water. Okay, and he typically dealt with strong acids and strong bases. Okay, so let me list out, just because I keep doing this, let me list out for you some strong acids. Hydrochloric acid, hydrobromic acid, hydroiodic acid, H2SO4, sulfuric acid, let's do some nitric acid in here, HNO3, 1, 2, 3, 4, 5, and then you have another one. You're losing it, Stephen. You're losing. Oh, acetic acid. It's a good one. HCH3CO2. And there's just so many more. But these are kind of your strong acids. And I think there was another one that I listed the other day, but those 6 will do you, especially these right here. But we're dealing with these, and you're going to see that inside of Bronsted-Lowry, he's going to use these as well, big time. Strong acids. And so some bases that are going to be used are going to be Na, sodium hydroxide, potassium hydroxide, magnesium hydroxide. If you notice, these are all doing that group 1, group 2 alkali earth metals, but the key is you're looking for some easy way to notate the Arrhenius is looking for that hydroxide. Easy way to notate this acid is to look for that hydrogen at the front. And so an acid is a substance that yields H plus ions in water. Let me show you an example of what's happening here. Okay, so let's see. Let's take some, what are we going to do? Let's just look at this one. So you have hydrofluoric acid, which is not a strong acid, but we're going to look at that one anyway. So you get hydrofluoric acid, and it's in water, so plus H2O, right? And then that's going to yield for us. What is that going to produce? What is that going to produce for us? Do you know already? You should. That's going to produce the hydronium ion, H3O plus. Also, you could, a lot of times people just write it like that when they're talking about acids and bases. But you know that it's not going to just exist as a lone proton by itself. It's going to mix with water. These are aqueous, my bad, aqueous. And what's our substance going to be at the end? Oh, man, we got some fluorine, right? Some fluorine in there. And that's negative. That's our anion. So another one, let's see, would be HNO3 and aqueous, and like it's not going to be by itself. You could do it like that, but we're gonna put our plus. We're gonna put our plus water, plus H2O. Then we're gonna put our yields sign, our produce sign. And that's going to yield for us what? It's going to yield for us another H3O plus, and we're going to give that plus NO3 minus, aqueous. So this nitric acid donated its proton, and that became H3O. Boom, boom. And then since it lost its proton, there it is. So this is going to be our acid. This is going to be our base. So what's our conjugate acid and our conjugate base? This is going to be our conjugate acid, and this is going to be our conjugate base right here. The substance that loses that hydrogen is going to be the conjugate base for Arrhenius and for Bronsted. Okay? So, yeah, let me draw a picture of what's happening here, because really what's going on is so important to understand. If you get this, you understand the concept, okay? So you basically have a container, a beaker, right? And it's got, let's say it's got water in it, H2O, or you could draw your particle diagrams. You could put your hydrogen in here and your oxygens, H2O. Wait, that's crazy. You got your hydrogen, you get your oxygen, and then you get your hydrogens, H2O, and you can put your particle diagrams in there. I wish I could copy and paste that. I probably could, but I don't have time. So you have your H2Os. I'm only going to draw a couple of them. H2Os in here. And you got, right now, you got a concentration of water automatically, right? There's a concentration right now of hydrogen inside of this mixture, inside of this, the universal solvent, concentration. Right now, let's say we take a dropper, and let's say we've got hydrofluoric acid, and let's say we drip. You get some HF. So you're dripping that in there, and what's happening is that the hydrogen concentration is doing what? It's increasing because there's more hydrogen going in here, which makes that acid. Okay? And now you do have that conjugate base of fluorine, but it's not really like, it's not producing OH minus, so this is an acidic reaction. But I just want you to understand this concept right here. You've got a concentration of water, a concentration of hydrogen in there already, but when you put the hydrofluoric acid in, it raises the concentration, and that is really what Arrhenius was going after. So hopefully that helped. Basically, what you should know is that Arrhenius deals with water. You should know that he's talking about the concentration increase of hydrogen, hydronium, H3O plus, or the concentration of hydroxide. So he's talking about the concentrations, and you should know the definitions right here. You could always go back and look. You should be memorizing these. And otherwise, that's the Arrhenius acids. Hopefully they helped. If you have any questions, just hit me up.